So, hey everyone, welcome back to another episode of our classes. Today, we are exploring another powerful string matching algorithm, the RabinKarp algorithm. This one is special because it uses hashing to efficiently search for patterns in the text. So, stick around to learn more about the advantages, disadvantages, and how to actually implement this code step by step. And also, we'll look at the pseudocode and as always, the practical implementations. So let's just start first with the definition. So by definition, RabinKarp. The RabinKarp by definition is a pattern searching algorithm that uses hashing to find the occurrence of pattern in the text. It calculates the hash of the pattern and compares it with the hash of substring of the particular text. So if that hashes match the character are compared to verify the match. This algorithm is especially used for searching multiple patterns for at once, and really it's too damn fast than the normal functions that we have inside of Python or any other languages. So what exactly are the advantages and disadvantages? So let's just start first with advantages. First one, efficient for multiple patterns. So I think there is a mistake on the slide. It has two different advantages: efficient for multiple patterns and simple concept. So efficient for multiple patterns. It can find multiple patterns in the text simultaneously by using rolling hash. And simple concept. The concept of comparing hashes is straightforward and easy to implement. Now the disadvantages. Disadvantages are pretty simple. Hash collision and worst case performance. Hash collision. Different strings can have like same hash values, a collision, which requires extra character comparisons, and that's where the hash collision happen. And this is a particular drawback of this algorithm. And then there is worst case performance. So what worst case is a time complexity that can degrade to O(n) into n, O(n) into m if collision occurs frequently. That creates a worst case time complexity inside of this algorithm, which is a bad thing, which should not happen. So now let's just take a look at, or let's just take a brief look at the steps of executing the RabinKarp before we move on to the solo code. All right, so the step one is compute the hash of the pattern and the first string of the text. Then step two is slide the pattern over the text one character at a time. Step 3, for each new substring, compute the new hash using the roll hash unique technique, not unique. Then there is a step 4, if the hash value matches, compare the actual characters to compare the match. And then the step 5 and the last one, continue sliding until the text is fully scanned. So this is the step-by-step process. So now we can just look at the pseudocode and or you can just take these steps and create a pseudocode for your own self. And once you have a pseudocode, you can now sit down and actually code the entire algorithm. That makes it pretty simple. Once you understand the step-by-step process, you can create a pseudocode, and once you have a pseudocode, you can write down the text, not the text, the code. All right, so here you can see, here you have the RabinKarp function. So the pseudocode is right up here. The first thing you do is create a function, then compute the hash of the pattern. Then for each window in text, if hash matches, compare the characters to verify the match. If match, compute hash for next in windows using rolling hash. This is the entire pseudocode that you have. So once you just understand the pseudocode, okay, this is the pseudocode, this is how the function is supposed to work. Once you understand that to a good level, then you can just sit down and code the entire stuff. So we'll just take this pseudocode and start doing this practically. All right, so simply we'll be creating two different functions. The first one is going to be hash value and the second one is going to be the RabinKarp. So the first one, the hash value. So hash value will basically have, I guess, three arguments inside of it. I'll just keep it s prime, s and then prime and then modulus. The first we'll just have h as 0 in the very beginning, where h is going to be pretty simple, 0. Then for Karen, so h into prime plus autochar modulus order char and then modulus and then return. H. Okay, that's perfect. So hash value is properly created right now. Now we'll just create a RabinKarp. So RabinKarp function will actually have two arguments, simply the text and the pattern. So the first thing that we need is a prime. So the prime I'll take 0, 1, 0, 1, and then we need a modulus, a large number for modulus. So 102, 9 plus 7. That seems pretty perfect. Then once you're done with that, we'll just have the length of the pattern and length of the text inside of two variables, m and n. Once you do that, we are going to be computing the hash for pattern and the first window. So how do we do that? By pattern hash and text hash. For that, we'll use the hash values functions we created. Pattern prime modulus, prime and modulus. Same for the text hash, but instead of pattern, we're going to be using the text. That is this one. Okay, perfect. Now we'll just have a for loop up here for hash matches. So if hash matches, then check the characters. That's what we want. That's what our pseudo code actually says, right? So we just be creating multiple if statements up here, and if we find that, then just return that the pattern found at index this. Okay, this is I, and that's perfect. Okay, text hash. So we are just simply recomputing the hash for the next window. So basically it's going to be the rolling hash. It's kind of complex as a process. Be really cooked enough to understand all of these codes and learn all of these codes. Or to be cooked enough to dedicate yourself to learning all these activities and codes and stuff. All right, so text hash modulus is equals to modulus, and then we'll just simply test the algorithm. So for that, I'll leave just two simple patterns, and then I'll just simply search both of them. Just I'll write the pattern and then see. Does it return the exact same thing? It has to return 0 and 9, I guess. Yep, it has to return 0 and 9. If it does, then I won the algorithm. First try. Okay, Python. And as I said, 0 and 9. It's the perfect output that we possibly expected. Alright, so now that's a wrap up for our dive into RabinKarp algorithm. I hope you found this video useful and learned how to use the hashing that can make patterns matching efficient. So don't forget to like the video if you liked it. If you didn't like it, then just dislike the video. And subscribe to stay updated with more algorithm tutorials. Thanks for watching. I'll see you in the next one.